Okay, so I guess we can start. Hello everyone. My name is Michal. You can call me Michael if you don't want to call me in Czech. Please don't call me Michal. I hate that for some reason. First, I'm sorry I got my slides in Czech, but luckily there's not enough of Czech text, so probably you will understand, and if you want I'll translate the Czech anyway. So this is a Czech police car used in, well, probably before everyone here was born. So yeah, let's talk about, we will talk about HTTP strict transport security, which is in short HSTS, and that's a way how to make the HTTPS better. I will not talk about HTTPS because probably it will be useless here in this group anyway. Let's talk about making the HTTPS slightly better. I will try to demo the attacks if the demo gods will be nice to us. We will probably need to give them the pizza later, but let's see. So when I was preparing this talk, I somehow ended up on this website. It's a Czech website which you can use to talk electronically to the government. It's called Datové schránky, which could be translated like, well, data inboxes or data mailboxes, something like that. And something actually, I was quite surprised that there is this message at the top of the website which says that if you want to actually access the application itself, you need to type, I mean really type into your browser this address. It's not a link, it's just you need to really type that. Well, I call this, personally, I call this HTML version 0 because it's not HTML, it's more, oh sorry. I forgot my proper device for that. It's not the HTML, it's more like just the ML. It's not, there's no HT. So I tried that. I tried to type the link into the browser. I did that just like everybody else would do, probably. And I did not type the, oh, come on. Okay. And I didn't type the HTTPS prefix. I just typed www and that address. So, because the browser will actually, fill it for you anyway, so you don't need to type that, right? And nobody does that in case of HTTPS. So I didn't do that. The browser filled it for me. The browser actually prefixed the address with the HTTP. It's like, okay, let's see what happens. So this happened. I ended up on a site which says like, oh, we want to make the site slightly more secure. So there is nothing running on the HTTP version, and if you actually want to reach the proper website, you need to update your bookmarks or you need to type the HTTPS yourself. It's like, oh my god, what's going on? And it says then in 10 seconds you will be redirected anyway. So it's just a 10 seconds delay. Just like, okay, it's a bit of WTF situation, but okay. So. Yeah, this is just slightly bigger, but it says what I said before, that you need to update your bookmarks or actually type the HTTPS as well. This recommendation probably comes from the OWASP recommendation, which says do not perform redirects from non-TLS pages to TLS login page. Probably somebody at the government says like, oh, that's a nice recommendation, let's just do it this way. But the recommendation has been removed in 2011, so probably the government needs to be updated as well, but well, I don't want to go into these details, probably. So, yeah, this recommendation is removed, so you can safely redirect from non-TLS pages to TLS pages, except when you're a government, I guess. So, and even if they would just do it based on the OWASP recommendation, they redirect anyway. So there was something really strange going on in government regarding this website. So still they do the redirect anyway even if the recommendation says they shouldn't. And this is just probably this is a joke in Czech, or it's not a joke. Probably the non-Czech speakers will not get it, but this is a really nice mistake in Czech grammar, and it's on the official website, so probably the whole website is kind of screwed up.
Well, I really get it even on Špaček speed.
You got it?
No.
So just don't write it like this.
Yeah, well,
It should be without the suffix ti. Even if you want to say deseti, just don't write it this way. So that's a free Czech lesson here. Yeah. So the reason why they did it this way is probably the attack which is called SSL strip. It works this way. I'll try to explain it. The attack is called SSL strip, even if there's no SSL anymore. So I try to call it HTTPS stripping, but the tool itself is called SSL strip. So it should be called SSL strip or HTTPS stripping. So it works in this way. If a user in a browser types an address without the HTTPS prefix, and he wants to actually end up on HTTPS login site, for example, he types the address of the site without the HTTPS, and he tries to, he hit load or go in his browser, and the browser first sends the unencrypted request somewhere. If the browser would be connected, or if the user would be connected to the network, which is controlled by the attacker, which is doing the active SSL stripping, if the user would be connected to some rogue Wi-Fi network, then the original request will not reach the server the user wanted it to reach. Because there's some bad guy in the middle, it's a man in the middle type of attack, and this guy in the middle will actually catch the original request, the original unencrypted request. So the original request will not end up at the server, but will end up at the bad guy's router or server, because he did some magic. And well, the bad guy will then re-request the original request. He will send it again to the server, and server will respond, hey, I'm not running on HTTP, I will just redirect you to HTTPS. It's like, okay, whatever. So the server sends the redirection, but not back to the original client, but it sends it back to the bad guy. So the bad guy is like, yeah, okay, whatever, I can redirect myself, that's fine. He will just then redirect again, and it will load the site on HTTPS, and the server will be like, oh, now that's cool, now I'm on HTTPS, here is the login page. So the bad guy will take the login page and will change all the links from HTTPS to HTTP. Also the action of the login form. He will just change it to HTTP. And then he will send the page back to the original user unencrypted. It will be loaded on HTTP with all the links changed to HTTP from HTTPS. So the original user will be like, oh, finally, the login page is here. Let's type some passwords. So he will not notice that the page is loaded over HTTP, because he doesn't know if it should be loaded over HTTPS or if it should be loaded over HTTP. Most of the users don't really care anyway. So he will just type his password 123 or something. He will type the password and he will submit the login form. So when the login form is submitted, yeah, if you remember correctly, the bad guy changed all the links from HTTPS to HTTP. So he will submit the form, the original user, he will submit the form, and it will end up at the bad guy's server again. And the bad guy, because the traffic is not encrypted, he'll be like, okay, I got your password, dear user. He will just encrypt the page and send it back to the server. The server is happy because he got the username, he got the login, he got the page on HTTPS. The user will be happy as well because the page was loaded for him. That's enough for the user. And the bad guy will be happy as well because he will get the username and the password. So this is like a win-win-win situation. Everybody wins, right? Except when they don't. So I will try to do a demo of this attack here. Let's see if it works out. So if you would be so kind and try to connect to the network, which is, I'll try, let's see if it works out. So there is a rogue Wi-Fi router running here. The network is called, I think, OWASP free. It's kind of evil from me, but yeah, I'm sorry for that. Oh, I'm not actually. So if you would connect to the network called OWASP free, don't worry, I will just sniff your traffic anyway. So then, oh, a second, I need to run the SSL strip tool. And then if you try to log into a centrum.cz email address, I know that you are not using it, but please try that for me. Don't type your real password, and we will see if it works out. So I'm actually right now a man in the middle. I don't look like one, but I am. I'm right now a man in the middle. I'm running the Rogue network here, and if anybody connects to the network, which is pretty easy because it's called free network, so everybody connects to that anyway. So they will be, they will be attacked using this SSL strip attack, except the other ones. So if anybody tries to log into centrum.cz, maybe you will notice that if you reach the login page, I mean the whole centrum.cz website, it's running on HTTP, but the login form should be submitted to HTTPS. Well, if you are connected to this network, the HTTPS action of the form will be changed to HTTP, so it will be easier for me to fix that. Hopefully there will be something in the logs. And there are some errors, but it's not what I'm looking for. I'm not sure if it will not work for us, which is quite probable. I have a video, so we can later watch the video. So if you go to centrum.cz and try to log in, type some bullshit password.
Connection refused.
Sorry?
Connection refused.
Connection refused.
I got it first too, and then it was fine.
Okay.
I think I just sent one request. Test.
I see something. Yeah.
Test.
I will just log in. I will just try to zoom in. Oh my god! I cannot scroll it down. Okay.
Yeah.
So you see it just a bit. Here is some user test, and his password was test. So this is a SSL stripping in action. If the SSL stripping wouldn't be running here, the username and the password would be encrypted because the form is submitted to HTTPS. So it would be encrypted and sent to the server in an encrypted form. And the man in the middle wouldn't be able to actually get the password in this way because the traffic would be encrypted and he cannot decrypt it quite easily. So he just do it in a way, the attacker does it in a way that he just changes the action of the form from HTTPS to HTTP, so he can actually easily read the traffic because it's not encrypted. Then the bad guy encrypts the username and the password and sends it to the server, so the server is fine. Here's my password, another user. So the website should be working flawlessly for the user, except it's running on HTTP, but it should be working. So this SSL strip tool doesn't work always for me. So I've picked centrum.cz because I know that it works there, and Centrum knows that as well, but they don't care. And I haven't tried. It was working also on alza.cz, quite a huge Czech e-commerce website before they migrated all their traffic to HTTPS. So there are some sites where it's working, and there are some sites where it's not working. And I haven't figured out why yet, but this is just a proof of concept. This is not supposed to be a real attack. But you never know if the users are attacked, for example, in cafes or not. They might be, but they just don't know. So, if you want to see the video, then it will be linked from my side, and it's exactly the same video of the same attack using centrum.cz. Oh yeah, and the video is just linked here as well. I will just post it into my site. So how to fix the situation? The problem here is that the user enters the address of the site without the HTTPS. If they would enter the site with HTTPS prefix, with the HTTPS schema, it would be loaded perfectly and fine, because there would be no unencrypted request which the bad guy can catch and somehow replay it or re-request it to the server. So if the user would enter the HTTPS right from the beginning, it would be fine. This attack wouldn't work. But nobody does that, right? Because it's just typing HTTPS and then switching keyboards and finding some strange characters. Nobody does that. And you actually don't know if the website you are trying to connect to, if the website is running on HTTPS or it's not. You never know. So luckily there is a guy who will try to fix that for us. And it's called HTTP Strict Transport Security, HSTS. The HSTS is supported in Firefox and Chrome. In Chrome since version 4, which is like ages ago. In Firefox since version 4 as well. And it's also supported in Internet Explorer. It's supported in the Edge version in Windows 10, but it's also supported in Internet Explorer 11 since I think like June or something like that. Microsoft has issued a patch for the Internet Explorer, and they have added, like retrospectively added the support for HSTS to Internet Explorer 11. So it also works in the latest version on Windows 7 and Windows 7. So which is kind of cool. The HSTS works in a way that this feature will redirect the user internally in the browser to the HTTPS version of the website. If the HSTS is not used for the website, they will, the original user will contact the server and the server will redirect the user. But if HSTS is used, the browser will actually internally redirect the user to HTTPS. So there will be no request sent from the browser to the server, which is unencrypted. So the bad guy is like, oh, okay, I cannot do anything here. So you can see the HSTS in the browser, and in Chrome it says that the status code of the original request, which is HTTP, it's not HTTPS, the browser itself will respond to itself with 307 internal redirect. This is not a server response, this is the internal response of the browser. The browser will send the request, but it will internally redirect itself before actually it sends the request to the server. So in Chrome it's implemented as 307 internal redirect, and if you see the internal redirect, it is the HSTS. It also says that the reason is HSTS. So this is not a server response, this is the browser response, like the browser was redirected internally itself. And then the request to the server goes in an encrypted way already. The HTTP Strict Transport Security is actually as simple as this HTTP header. This is a response header from the server. The server says to the browser that this site should be accessed only over HTTPS in the next 31 million seconds, which is a year. So the browser should then send a request to the server, even if the user doesn't type the HTTPS prefix, the browser should load the website over HTTPS. It will redirect itself internally for the next year. You can also include the include subdomains token, which means all the subdomains on this website will also be HSTS supported, or how to say. It will also load all the domains, all the subdomains over HTTPS, even if the user doesn't enter the HTTPS prefix. So this is just the HTTP header coming from server to the client. And then once the client has this information, all the subsequent requests will be sent over HTTPS, will be internally redirected to HTTPS. If you are going to use this header, do not forget to set it also for the root domain, not just for the www.something.com, but also for something.com. Also set it for example.com, not just for www.example.com. And then you can use the include subdomains, and all the subdomains will be loaded over HTTPS from now on. If you have been listening carefully, and I hope so, then you know that the browser needs to send a request first, and the server will respond with this HTTP header, which is like on the previous slide. So the first request can be still attacked by the attacker, right? This is a principle called TOFU, which is trust on first use. We need to trust the network on the first usage, which is probably not a good idea, right? Because you never know. But it works in this way. But luckily, there are some features of the HSTS that can be used to also prevent that, so that we can also trust the first request, which is going from the server to the browser. It's called a preload list. A preload list is a list of websites which are built into the browser, and you will have the list initially, even after you install the browser, you will have the list loaded into the browser, even before sending the first request. This is a built-in list into the browser. And all the websites which are on this list will be then loaded over HTTPS only. There is no way to load it over HTTP, well, except we will see later. So this preload list is maintained by Chromium developers, by Google. It looks this way. You can browse it because it is. You can find it on chromium.org/HSTS, and there is a link to full list here. It's just the JSON data in the Chromium source, so you can just see all the websites which are then loaded over HTTPS. There's like 3,000 websites right now. And all these websites, like bestweddingquotes.com, well, whatever is that, they will be loaded over HTTPS only. Because there is a flag then here, and it's called force HTTPS. And if there is force HTTPS, the website will be loaded over HTTPS only. There is a lot of interesting websites. Like there is a website with photos of nude girls, which is loaded over HTTP2 or something like that, and it says that it's just a test for HTTP2. There's a lot of nice websites. So this list is built into the Chromium browser or into Chrome as well, but it's also used by Firefox and by Internet Explorer, also by Safari. So you just need to get your website to this list, and then it will be shared across the browsers. Of course, Chrome will get it first probably, but Firefox will get it later as well. This is also loaded into the Tor browser. Tor browser also supports HTTP strict transport security. Sorry. So this is just one list, and it's used by all the major browsers right now. It's also used by the mobile versions of the browsers. So yeah. How to get into the list? That's a good question. Thank you for that. So, yeah. To get into the preload list, you need to load this website, hstspreload.oxboot.com, and then you can. It's just a simple website with a simple input form where you actually put your address. Somebody will then verify it manually. They will run some tests on it, like if you actually support the HSTS or not. And then they will put you into the list. You need to also include the preload token to the strict transport security header. This is like an agreement or something that you actually want to get into the list. Because some of the websites, for some reason, they don't want to go into this list. I don't know why, but they just don't want to. So this prevents the bad guy or some guys trying to play funny jokes on different websites to actually load all the websites. So if the website is not using the preload token in the strict transport security header, they will not get into the list. Yeah. To show you the website looks really easy. It's nothing special. It's just a simple website with an input form, and there are some rules written below that you need to you need to issue the header with at least 18 weeks max time or max age. You need to include the include subdomains token, you need to have the preload token, and you need to have the strict transport security header on the domain, even also on the root domain, not just on the www something domain. And it will take some time because first it will get into the source, then it will get into the canary version of Chrome, then into the beta, and then into the stable version. But finally, eventually, the website will make it there.
Sorry, just to ask.
Yeah.
Hopefully they check the content of the website.
Sorry?
Sorry.
No worries.
Hopefully they check the content of the website before they can add it. So for example, if I want to have my porn page running on HTML.
If you want to add your porn page, it's going to be probably fine. It will be added because it's not illegal, right?
Right, yeah.
And Google and these guys, they are not police. They don't care.
Yeah.
Probably, if you would love to add phishing site for Google, probably you will not get there. But the porn site is okay, right?
It is indeed.
Yeah, I wouldn't love to be a guy checking all the websites anyway, but if you go through the list, there are some porn sites, definitely. Just don't go through the list right now, please. So, okay, so once the site gets into the list, there is no easy way to get out of the list. You can mail somebody at Google and ask them to remove your website from the list, but and it will take some time, and especially if the list already reached the stable version of Chrome, it's gonna be slightly problematic. But I don't see a reason why to actually get out of the list when you're there once. Because if you support HTTPS and you're sure that you can handle the load and you can handle the users and everything, probably there's no reason why to actually get out of the list. But somebody somehow sometimes wants to. So if you would love to use the strict transport security feature on your website, and if you will be building it, please don't use large max age in the beginning. Just use a few seconds, like a minute or so that actually you can test it. Don't add the whole year there in the beginning initially. And do not add the preload token. Because if you have the preload token there and you have everything done correctly, you might end up in the preload list, right? So for testing, use the max age of 1 minute or 2 minutes or 10 minutes, that's fine. And do not use the preload token, because otherwise you might end up in the list. And I have seen some of the major websites in Czech Republic that they were loaded into the preload list, but they were not using the guy who was maintaining the list. He said that, oh, when I was actually putting the website into the list, it was using this strict transport security header. And then I asked the guys who are running the website, they were like, oh yeah, we were just testing, And they ended up in the preload list. So they had to mail the guy in Google and ask him to remove their website. So, bit of stats on the preload list. There is just 3,300 domains right now, and just 67 Czech domains, which is not that bad, but I guess from out of the 1 million something Czech domains, just 67 Czech domains, it's kind of bad. From the Czech domains, there are some e-commerce sites like Mall, Slevomat, Alza, etc., and some online magazines like Zdrojak, also on my site, of course. Yeah, right now the list of 3,300 domains is not loaded into your browser, because this is the number from the source. It doesn't mean that all the sites are loaded into your browser. You would probably need to check a different branch, but these domains will eventually end up in the browsers. What's kind of interesting is that in the preload list there is no bank, no single banking site from Czech Republic. I mean, it's not in the preload list. And it's kind of funny because, the banks, they say that, oh yeah, security is our top priority. Yeah, except when it's not. If it would be their priority, they would probably be all in the preload list, but there's no bank. So if you would be, if your marketing department would be using something like this website, it says that all the communication runs encrypted using the same system as the banks are using, which is not the best one right now. So try to be better than the banks. The banks are not, you know, the role models in doing encryption over the internet. So just like anything else, the HSTS can also be bypassed. Even if it's the best thing we have right now, it can be bypassed. Because the header says that it should load the website over HTTPS this amount of seconds in the future, just like in the next year. But what if we somehow manage to change the system time on the user browser or on the user computer? So what if we change the time, for example, 2 years into the future? That's possible. There is a tool for that, and it's called DeLorean for some reason. You can download it. It's not my tool. It's a tool released at the DEF CON conference in Vegas this year. And this works exactly for this. It is an NTP man in the middle attack tool. Man in the middle. There is a typo here, sorry for that. This changes the time because all the computers are right now trying to get the time from the internet. So you can also man in the middle it and change the response from the server. It is possible. Actually, it's the guy who wrote this tool says that it's kind of easy to do it on Fedora and also on Ubuntu because Fedora is asking every minute for the time in the default settings, and it's kind of hard to do it on Windows because Windows ask for the time from the internet only once per week or something like that, and it's not possible to set the time into the future no more than, I believe, 10 weeks or 18 weeks or 18 hours, I believe. So something like that. It's not possible to set a time that long into the future. But in the other operating systems, it's possible to set the year like 2 years into the future and it's fine. So if you manage to set the time 2 years into the future, then the HSTS from the browser will not be used because the browser will be like, oh yeah, I would love to load the site over HTTPS, but it's 2 years into the future and I shouldn't do that because the max age says that I should do it only for a year. So, and then the attacker can also do the SSL strip attack again. There is another thing with the preload list. The preload list is not actually forever. The preload list in the Chrome browser is only for 10 weeks. It says it in the source that you know, we thought that the preload list is gonna be forever, but no, it's just on 10 weeks. Different browsers like Firefox and Safari, they have it forever, but Chrome doesn't. And it's in the source. And it's in the source written that it's just for 10 weeks. Here. In the transport security state file, it's trying to see if the build time of the browser is actually in the 10 weeks time span. So for Chrome, it's just 10 weeks. And Google says that it's because if there would be some website which got into the list by mistake or something like that, they will automatically drop out of the list after 10 weeks. Google usually releases new major versions or new stable versions every 10 weeks roughly, so it should be fine if you are staying on the stable versions or the updated stable versions. But the preload list is not forever, it's just for 10 weeks in Chrome. Even if it looks like it should be forever, it's not. Another feature of HTTP strict transport security is if there is an issue with the certificate, if you try to load the site and there is an issue with the certificate, like there is someone trying to do a man-in-the-middle attack and changes the certificate, then the strict transport security feature will not allow the user to continue. If you compare these two sites, there was an issue with the certificate. Somebody was doing a man-in-the-middle attack and presented a different certificate or invalid certificate. Then this banking site says that, oh yeah, I can proceed to the website even if it's unsafe. I can still just click it and I will end up on the website. Well, if the site would be using strict transport security, then there is no continue button. If there is an issue with a certificate, it definitely means that it's an attack. It's not like somebody is trying to test something or something like that. It's an attack. So if the website is supporting strict transport security, the user will not be allowed to continue to the website. It says that you cannot visit this site right now because the website uses HSTS, and network errors and attacks are usually temporary, so just please wait a few more minutes and it should be fine. So this is another feature of HSTS that actually the user cannot continue if there is an issue with the certificate, because that most probably means that it's an attack. So I hope that do any of you actually have any website? Raise your hands who is running a website. Okay. Okay, now raise your hands who is running it over HTTPS. Oh, that's cool. Nobody. Are you running it with HSTS already? Oh, cool. And who's gonna edit after this talk? Nobody, cool. Great success. So if you are that lazy, you can still use this extension. It's called HTTPS Everywhere. It's from EFF, the Electronic Frontier Foundation, and this is like a local HSTS for the user. You can use this extension, and then this extension also have a list of websites who are running on HTTPS only. And if you go to the website which is in the list of this extension, it will load over HTTPS automatically, immediately. So you can use this extension in your browsers, and you can also add the websites you know who are running over HTTPS only, for example, like your banking site. You can add it manually to this list, and then the site will be loaded over HTTPS automatically, even if the website developers are lazy to add these strict transport security headers. So you can just use it like a local HSTS thing. Yeah, and I recommend to use this extension so that you are not vulnerable to the SSL setting attack. Yeah.
Does it help to get A+ encryption rating, like Consis or?
Well, you can actually get A+ rating only if you support the strict transport security. It helps, although some of the attacks which will downgrade the grading to B or C, they are not. Some of them are really hard to actually execute, but it's better to have A or A+, because that's the best HTTPS setting you can have. So that's all from me. If you have questions, just shoot them. Yeah?
Another question about one recommendation. Is a good recommendation to, when you are deploying strict transport security, to use short max time? But also it's good to not include subdomains per meter if you are not 100% sure that there is not some
sure, that's a good thing. Thank you for that. Yeah, you need to be pretty sure that all your subdomains are running on HTTPS. For example, if you are running a website and you have a blog on domainblog.something.com, and this blog is, for example, a third-party service, it's not your service, you are using Blogger or something like that, they might not support HTTPS. So if you would include the include subdomains token, please be pretty sure that all your subdomains are running on HTTPS. Thanks for that.
And also with valid certificate.
Yeah, sure. And valid certificate, which is not expiring tomorrow. Yeah, thanks for that. So any other questions? If you would have a question later, you can just follow me on Twitter. There is a stupid handle which I'm using because I was young and stupid before. Now I'm not young anymore. And there's 0. And you can also shoot me an email if you would have a question regarding HTTPS or whatever else. So, yeah. I guess that's it. Thank you very much.